before addressing this problem, if you haven't already seen my video on the product rule, it's linked in the description. The first thing that we do is assign u and v. So u is going to be x squared and v is going to be cos x squared. To differentiate sine and cos, this is probably the best method to use in case you are stuck. If you write down a list, you differentiate to go down, you integrate to go up. So if I have cos x differentiated is sine x. If I had minus cos x and I want to integrate, it goes up to minus sine x. So let's first differentiate du dx. It's going to be 2x. And dv dx, we're going to actually use the chain rule. So let t equal x squared. That means v equals cos t. dt dx would be 2x. And dv dt, let's remember this. So we're at cos x or cos t, and that differentiated once will become minus sine t. Minus sine t. We multiply it across to get dv dx, which is 2x minus sine, and we substitute in our value for t, which is x squared. So we've got dv dx and we've got du dx. The product rule formula is u v dash plus v u dash. So we now plug in our values where v dash and u dash is the universal notation for something that has been differentiated once. So v dash and dv dx is the same thing. So let's do u, plug that in, which is x squared, times v dash, which is here, minus 2x sine x squared, plus v, which is here, cos x squared, and u dash, which is 2x. We can now clean up a little bit, but not very much. So we're going to now get, I'll rewrite it the other way around, 2x cos x squared minus 2x cubed sine x squared. So that's now been differentiated. Let's now use the product rule to differentiate this. So u would be 2x cubed, du dx would be 6x squared. We have v, which is sine 5x. I'm not going to write out the full chain rule for this. If you are struggling with the chain rule, I do have another video that you can watch so that you can work that out. So dv dx would be 5 cos 5x. So now we can plug this in to our product rule. So u would be 2x cubed and dv dx would be 5 cos 5x plus v du dx, which is 6x squared sine 5x. It can be neatened up a little bit, but not too much. We can sort this out at the top. So you're going to have 10x cubed cos 5x plus 6x squared sine 5x. So that is the differential